I gave you 11, right? Now, again, use your calculator. Put it in your L1 and sort it. It makes life a lot easier for you to actually see where your data is. You can even rewrite it right from your calculator so that you have it in order for you to look at. Go to the last 5 numbers. These are called your 5 summary numbers. It gives you your min, your max, quartile 1, your median, quartile 2, quartile 3, and your max here. Know this formula, this interquartile range. Because you're looking at the quartiles, the only quartiles you see when you look at your 5 summary numbers are quartile 1 and quartile 3. The median doesn't show up as a quartile, so that's good for us. So we're going to subtract these guys. And you want to subtract because you want to stay positive. So you're going to be Q3 minus Q1. That's where you start. You take that answer and you multiply it by 1.5. Now, what it's doing is this. Here's my quartile 1. Here's my quartile 3. It's in my box, right? It's saying if I subtract this number from quartile 1, so quartile 1 minus that puts me at 48. Quartile 3 plus 9 puts me at 72. This is the allowable data that I consider normal. Anything outside of that, to the left or to the right, I consider an outlier. Now, go to your min and your max. Is your min within this? Your min is right in here, 51, right? So do you have an outlier to the left? No. My max is 80. Oh, that's definitely outside of this. So I know 80 is an outlier. And I want to see, do I have anything else that's higher than 72? Do I have anything else higher than 72? No. So just 80 is my outlier. That's how we tell. We use this formula. Interquartile range, multiply it by 1.5, subtract it from quartile 1, add it to quartile 3. It makes sense if you do a drawing, and so you can kind of see it. Okay, same thing with this guy. We're going to find your interquartile range. We're going to subtract it from your quartile 1, which is 13. Minus 4 puts us at 9. We're going to take your quartile 3, 17, and we're going to add 4. This puts us at 21. Anything outside of these numbers are outliers. But I can tell by my minimum. Always look at your minimum and your maximum. My minimum is within here. My maximum is within here. So this group has no outliers. And everybody can make the box and whisker graph? I forgot a title, so don't forget to give me a title. I don't think this one had any title to it, right? This was a set of numbers, yes.
Did Q1 minus 9 and Q3 plus 9 to determine if there's any outliers, right?
Yes.
That's one reason.
Yeah, that's why we use this interquartile range. I don't think this question asked it, but I just threw this in there because they asked you to find the interquartile range. Oh wait, we forgot to multiply it by 0.15. Sorry. So this would give us 6. So I have to subtract 6 from this. 7 and add 6, 23. So that gives us the allowable 7 numbers. I don't think they asked it, that's why I forgot to multiply. But if that's what you're looking at, it's so much easier to look at when you have your box and whisker up there, because you can physically see, oops, my minimum is within there, my maximum is within there. Okay. What was the next number I gave you guys? 26. I passed it. Okay. Again, do a one var stat. Everything we do in here is one var, not 2 variables. One var stat, put it in. If you like to sort it, make sure you get the box and whisker there. There's a title to it, vacation days. And you should be good. Can everybody do this? Key point. This is a number line. The one thing you want to avoid is taking these values and putting them down here. That has to be a continuous number line. So, because if you took those values and put them there, everything would look equally spaced apart because that's where you put it. That's where you made it. So this is a complete number line from low to high. And then your points go there. So now I could ask you, actually, which quartile has the most variability in the data? Which quartile would you say has the most variability? Which one is the most spread out? Which section of those 4 sections is the longest section? The fourth. Remember, this is in quarters. So this is the first 25%, the second 25%, the third, the fourth. Kind of close between this one and this one. If I wanted to, I could subtract their numbers and tell for sure, but it kind of looks like that one might be. Which one has the least variability in the data? The first or the third? Yeah, probably the first. Looks like pretty much, and they're both 2. So the first or the third. And actually the third is a little bit over, right?
Yeah, 'cause that's like 4.5.
Like 4.5. But that can't be, it has to be my drawer, my thing is off, because there was no halves. My pens are always off on these things. Okay, so everybody's figuring out where those quartiles are coming from? Think money. All right, so this guy, we had a lot to do here. This was the big one. The ages of 30 executives. We sorted them. I sorted them here. And let's take a look at this. One day up and out. So we're looking at ages, and we wanted to find out what number is this? 36 to 38. Okay. 30 executives. Find a percentile that corresponds to an age of 40 years old. Now, my 40 years old says, here's my 40. How many entries are less than 40? 3. How many total entries do I have? 30. Times 100. Be careful the way you divide this. This has to come like a regular percent. If you divided it the other way, if you get 10 times 100, that's 1,000. You don't have 1,000. So remember, part over whole, part over whole. So it comes at, when we divide this out, and we get 10, 1, whatever we get 10%. So 1 over, reduce this down, 1 over 10, 10%. And we get the 10th percentile. Okay, use this formula. What you might want to do is make sure either sort it in your calculator or rewrite them out. Go through your calculator and count them. You need to have them in order. Find the one that corresponds to 56. Well, technically you should start with the first one. That is, I don't know which one they started with. So God bless you. The number of entries less than the 56. Whoops. Put my 56 back in there. I think they took the middle 56. Let me see. They took the first one. These must be where my quartiles are. These are my quartiles. I don't know what this divide sign means. That's probably where the median is. This is probably where your median goes, in here, 49. And that's another quartile over there. Okay, so find the first 56, count the numbers in front of it. Count the numbers in front of it, you get 21 divided by 30. You just put it in your calculator, multiply it by 100. 70th percentile. Which ages are above the 75th? So you have to find where your quartile is and count those ages. So once you count those ages, stop at the 56 and count the rest. You could stop right here and count these guys. Also 30, if you take 30 divided by 4, you're a little off because you're even numbers. Remember when you count the medians? When you're an even number, you're going to have to take the average between the two, which is why we took the average between these two. So you have to be careful, and then if you take the average of the next, you'll find the exact number. Which ages are below the 25th percentile? And we go back to your 25th percentile. Sorry, I have to keep moving back and forth. Here's my 25th percentile and my ages below. You can't do this without sorting it. So make sure you sort this first. Are we all okay with that? Quartile 1 is your 25. Think of money. 1 quarter is worth 25 cents, 25th percentile. Quartile 2, that's your median. That's half of your data. That's 50 cents, 50 percentile. Quartile 3, 3/4, that's 75th percentile. Then you have 39. So I was just kind of asking you to figure out where your z-scores would be. Now, if you kind of think of this as your normal curve, and you think of where is your mean, median, and mode, smack in the middle. This is where your mean is, and your mean, your median, and your mode. If you kind of get a judge for this, excuse me, thank you, the negative z-score, anything to the side. So, hey, the positive z-score to the side of it. C, smack in the middle, where it doesn't deviate off the mean at all, that has to be sitting on the mean when it's 0. That's your B. Everybody good placing these, just to get a feel for this? This is a great graph, just so that you can kind of build an understanding about where is this going. We're going to work a lot more with these. Thank you. Again, here's sort of your normal curve. Here's your mean in the middle. That's where your 0 would be. So your negative, we can kind of get rid of your negative there. And these, this is a number line. So this is 0, and then 1, 2, 3. The one that comes the closest to the mean, 0.77. The one furthest away, 0.154. And these, see, these are almost symmetrical, aren't they? Negative 1.54, positive 1.54. Those are symmetrical. Equal distance away from the mean. Just so that you kind of get a placement for it. We look at standard deviation a little bit different. You kind of do it in Algebra 1. And in Algebra 1, we kind of just wrote in the calculator and we look for standard deviation. We do like what your percentages are. We're still doing that part of it, but we get a lot more involved than that. So if you build just a basic understanding, I'm happy. I don't know where that one came from. Up there for some reason, and because I don't like theirs, the way they compare their data sets. I didn't write theirs, so I think I put an example up for ours. So work this example with me. If I took a test in statistics and I got a 23 with the standard any test, I didn't give you a test. Do you guys have this? Or did I just put this here for some reason? I must have just put that there for some reason. Okay. So let's just leave that alone. I don't know why it's there. Let's just move on. I don't like their comparison ones anyway. All right, this is important that you know how to do this. Can everybody lay this graph out? With the mean in the middle, count the standard deviations above and below. Okay, so you're laying out your mean. This is the important part. You start like this. This is 0. Keep your standard deviation numbers down here. Keep your x values on top. Your book does it the opposite. But it's much, much easier if you do it this way, the way I do it. This is 35,000. Your standard deviation is 2250. Just keep adding your 2250 all the way up. Then subtract it all the way down. And that'll give you this spread right here. Now remember, this is a number line from 0 on up. This is your percentages that you're accumulating from the left. When we look it up in that table, that gives us a percentile that we're looking up. At the area to the left of that number, that is the same as if we gave it a rank, if we gave it a percentile. So the first score is that they're looking at is 34,000. 34,000, get a feel for this, is to the left of your mean. So is your z-score going to be positive or negative? Negative. So when I use my z-score formula, I notice my x value, when I subtract my mean, has to give me a negative number. This is a good way to remember. If I subtracted it the other way, something's wrong. I need a negative number. So I do that, I divide by my standard deviation, and does my point, negative 0.44, come between 0 and negative 1? Doesn't it? So I should see that it works. I take another value, 37,000. Right here, a little bit above my mean, a little bit before the 1. So I should get a number that's very close to 1. When I look that up, when I work this out, I get 0.89. My 31,000 puts me over here, right before the negative 2, right before my 30,500 something marker. When I do that, I get negative 1.78. Okay. These guys fell smack in the middle of, smack on your graph. At 30,500, 30,500 is this. It's 2 standard deviations below the mean. How do I know this is my 2.5 percentile? How do I know this? If it's 2 standard deviations below the mean, how do I know what my percentile is? How do we find it? Look at table 4. And look up negative 2. How would I look that up on that graph? What exactly am I looking up for negative 2? Here's my chart. I'm in my negative z-scores, and then I've got 0.09, 0.08, all the way down. On the negatives, these descend, those descend. So what do I look up on the left-hand side if I have a z-score of negative 2? I'll give you a hint. It's negative 2.0. Look up like negative 2.0. What do I look across the top one for? 0.09, 0.08, 0.07, 0.00. So negative 2.0 plus 0.00, doesn't that still give me negative 2? And that area, I just moved the decimal. I rounded it and moved the decimal. It's the area to the left of that number is what's given when it intersects. So what number does that give you when this intersects? 0.0 to what? 5 something, right? 0? Hello? Okay. One standard deviation. One standard deviation above my mean tells me you covered all this amount, 50%, and all this section, which my plus or minus 1 is 68%. So my just plus 1 is half of that, 34. So I'm at the 84th percentile. My 35 is smack in the middle, right? Smack in the middle. I didn't deviate off that mean. So isn't the mean in the middle of my curve? How much percent of my curve is to the left and to the right? 50%. I'm at the 50 percentile. I am the average person, smack in the middle. Okay? And this we'll get to tomorrow. Remind me to start here tomorrow.